A car accelerates from 20 meters per second to 50 meters per second in approximately 5 seconds. If I'm going to draw what that looks like, I'd probably start and say that's 20. Up here is 50. And it's going to take 5 seconds. That looks like what's happening. Would you guys agree with that? This is all you're asked to do. A supporting graph and then answer some questions. What is the acceleration of the car? The slope of the line. Right? This is a velocity versus time graph. So looking at what velocity versus time graph, slope is acceleration. It's asking for the acceleration. So 50 minus 20 over 5 equals 6 meters per second squared. What is the displacement of the car? Area, which is just the trapezoid formula. So delta x equals 1/2 times 5. 50 plus 20, or 20 plus 50. So 70. 70 times 5 is 350. Half of 350 is 175. That's what you were asked to do. So, yeah, I'm not going to have much sympathy if you think this is hard, because this is not. So correct all of your mistakes, because many of you had them when I walked by, and try number 2, which is exactly the same. And I want to see, I'm going to pick on some of you to kind of tell me what you get. They get harder. These aren't the hard ones, though. So let's look at number 2. Because there's more that I want to be real clear. I can ask you to do something else that was not asked. I could ask you also to make the position versus time graph for each of these. Do you think you could do that too? You should. So maybe I'll model that real quick. What would the position versus time graph look like? Well, that didn't work at all. So, don't really know where the object is, but it's always traveling forward, so I'll make the origin the start of the car. I know that it is displaced 135 meters in 5 seconds, right? None of this is in dispute. I'm just using the stuff we just solved, right? At time 0, the object's speed is 20, yeah. I'm sorry, yes, 175 meters. Thank you. At time 0, the car's velocity is 20 meters per second. So the slope at time 0 has to be 20, because slope is velocity for a position graph. And then after 5 seconds, the slope's got to be 50. So something like that. Concave up, getting steeper. That's it. There's just not a lot of meat here. This is not a lot. All right, let's look at number 2. You do all of those things. You do them. I will come around and look at yours. It's slowed from 6 meters per second to rest. So 6, rest, 3 seconds. That work for you guys? What is the acceleration of the ball? Slope, I guess. I want to also point out VF equals AT plus VI. I don't have to draw this picture. I mean, the picture is there to serve a function. But once we understand how the function works, I don't think we need the picture necessarily. Because this is 0 equals A times 3 plus 6. Do you kind of see where I got those things from? I mean, there are 5 motion variables. The problem presented me with 3 of them. Right? It told me the initial velocity was 6 meters per second, the final velocity was 0, and the time was 3 seconds. Right? It gave me those 3 pieces. I look at the formulas, and the formulas have 4 things or so in them. You can just plug them in and figure out what it must be. So that suggests that A is going to be negative 2 meters per second squared. It's got a negative slope. What distance did it roll? Well, delta x is going to be equal to 1/2 times 3 times 6 plus 0. 9 meters. By the way, units have to be on your answer or else they don't really count. So I know that in your homework you don't always do those kinds of things, but if you want credit, I would encourage you to do that in your homework too, so that's automatic for your test. Position versus time graph. The object traveled in the positive direction the whole time, but was slowing down. So I'm going to say 0, and I'll put 9 meters here. So it started here, and after 3 seconds is here. It had a positive 6 slope at time 0 and had 0 slope at time 3. Bless you. That good? Concave down. Do you guys have your calculators? Might as well go the extra mile here. I'm hoping you know how this works. Delta x is x final minus x initial. This is 1/2 times a, which we found to be negative 2 t squared plus 6t. So x final equals negative t squared plus 6t plus 0. Can you put that into your calculator and graph it? Right, this is how your calculator works, right? It's got the y, hit the y equals button in the upper left. You put this function in one of your y's, but you have to, I mean, you have a button that has like x, theta, t, and n on it, right? So that it's trying to tell you it can be any of these things. And it will produce a graph. Now your graph is probably going to go beyond 3 seconds. It's probably going to produce more than that. But after you get it in there, just hit zoom standard or something so you can get a kind of a picture of it, or zoom fit, one of those. Can I see? Yay, I mean, this is pretty straightforward, isn't it? Just trying to make sure we all know how our calculator works. Some of us know how to do this, and some of us do not. If you hit the trace button will let you kind of figure out stuff too, right? You can move along the function. You're allowed a TI on the exam. So that's the one thing the TI will do for us. And if you don't have a graphing calculator, it's not required. It's just one more way you can kind of check your work. All right, just a thought. Consider the ball in the previous example. It rolls up the ramp at a speed of 6 meters per second. But instead of being caught at the top, it rolls back down until it's traveling 8 meters per second in the opposite direction. And I looked around and saw some people's graphs about this. And I saw some mistakes out there. So let's handle what could be some mistakes. If 6 meters per second is in the positive direction, what can we say about the 8 meters per second? It's going to have to be negative. Yeah. So I think I'm probably looking at something that looks more like that. Right? Part of its motion is in the positive direction. Part of its motion is in the negative direction. Is it the same ramp as before? It says, consider the ball in the previous example. It rolls up the ramp. I think we can assume it's the same ramp, can't we? This is important because that means that I can probably keep the fact that the acceleration was negative 2 meters per second squared. So this is 6. This is 8, but negative. So I think my initial velocity is 6 meters per second, and my final velocity is 8 meters per second. Now, if the ramp is the same, how long did it take? I don't know what t is. Probably figure it out. There's probably a lot of ways you could do so. And I don't know what delta x is. You can probably figure it out. But I'm not sure if you know different ways to do so. But I'd like to show you some stuff, but how many of you think you could figure this out from here? Okay, so I think you have some methods. Try them. I will point out one of your relationships has these 4 things in it. Excuse me. You guys know what I'm saying when I say that to you? Look at the relationships on the other board. Is there one of them that has all 4 of those things in it? Do you see which one I'm talking about? So perhaps start with the relationship. Maybe not even use the graph. Figure out t from the relationship. Be careful, I'm being a little deceptive here. I left something out. And if you're not paying close attention, you'll make a mistake and get the wrong answer. The right answer is 7 seconds. It clearly has to be more than 3 seconds. It's going to take longer to stop and come back. And if I just look at the graph, if it took 3 seconds to get here and it changes 2 meters per second each second, it's going to take another 4 seconds to get here. But if you don't know what the mistake is, I'm going to show you something that you're not paying attention to that's going to mess up your quiz tomorrow. Remember, each one of these is a vector. They have direction. So if 6 meters per second is in the positive direction, then 8 meters per second is in the negative direction. I have to be aware of that. I have to be thinking of that. So negative 8 equals negative 2t plus 6. That suggests that t is going to be 7 seconds. Right? Negative 8 minus 6 is negative 14, and negative 14 divided by 2 is, or negative 2 is 7. I'm leaving out arithmetic, but if you need me to do the arithmetic, I can. Does anybody need me to do the arithmetic? Then, first thing I would probably do is subtract 6 from both sides. So -8 minus 6 equals -2t. -8 minus 6 is -14 equals -2t. And then divide both sides by -2. And t equals 7 seconds. I will be kind in the beginning. If you ask me to do arithmetic, I will. I won't do it the whole year, but I will until you acclimate. Now I have time. Since I have the 7 seconds of time, oops, wrote down the wrong place. I have the 7 seconds of time. I think I have enough information where I could figure out the displacement. Do you guys see that? So you should be able to do it now. So -7. Is there anybody who needs me to show you where that came from? We got our -7 meters and we're okay? We all good? All right. They're gonna start getting different, and I'm okay with that. Ready to start this one? Why don't you give this one a shot? Because this back page, I'm changing the rules. What's the velocity at time 0? 0, okay? How long is the interval? And how fast are they going at 10 seconds? We don't know, do we? We know that they are probably accelerating because we were asked to find the acceleration. Can we all agree with that? So it probably looks something like this, but we don't know where this is, right? We don't know how fast they're going here, do we? We do know that this area is 100, correct? Don't they tell us that the area is 100? And if the area is 100, can't we figure out the height of that triangle? Can you do that? Can you figure out the height of the triangle? Go ahead.
How do you know when it's like a straight or curved line?
Our velocities for the time being are always going to be straight. I'm sorry, our accelerations for the time being are always going to be the same value, which means our velocity graphs will always be straight.
Oh, okay.
We're not drawing position graphs. We're just drawing the velocity graph
Okay, so only on position.
for now. We're dealing with, like I said before, we're dealing with something called uniform accelerated motion. So we're saying that the acceleration is a constant. Have you got it yet? Figured out how fast they're going? How fast are they going? 20 meters per second, yeah. If you're stressing out about this, How do you find the area of a triangle? 1/2 base times height. I know the area is 100, and it's 1/2 base times height. This height has got to be the final velocity. So, do you see where it came from? Once you have that height, can you figure out what the acceleration was? Can you figure out the slope? Because once I know that this is 20 meters per second, rise over run suggests 20 divided by 10. Nothing new, right? All the same stuff, just mashed together differently. Look, you guys struggle with this, and it's like this all the time. I'm going to give you a framework. I want you to start thinking about this framework. I am not that interested in the graphs. I never have been. The graphs are a means to an end. Do you guys, look me in the eyes, I know that means turning around, do you see where those three relationships came from relative to the graphs? I spent weeks on it already now. Okay, so if you are okay with this and you understand where those came from, the graphs were just designed to help us get those. Have you noticed every one of these problems revolves around these 5 things? These are called the 5 motion variables. And every one of these problems is revolving around these 5 things. You have at your disposal currently 3 relationships that involve those things. How many of those variables are in this relationship? 4. Thank you. How many of those variables are in this relationship? I just moved the T to the end. And how many of those variables are in this relationship? 4. You've learned a little bit of algebra, so you know that if I want to solve, it looks like I'm going to have to be presented 3 of these variables, right? Because if I pick one of these equations, I will need 3 things to solve for a 4th. Does that make sense? This problem presented you with 3 things. It said the runner traveled 100 meters with an initial velocity of 0 and took 10 seconds to do so. Notice, I'm not even looking at the graph. Don't care about the graph. I'm just looking at, that's what was given in the problem. These are our 3 relationships that describe any straight line velocity graph. So, is there a relationship there that has those 3 things in it? Sure. More than one, I think. But the important thing is that if I want to find something that's not here, I could probably find it by plugging into one of those relationships. So for example, maybe I want to find the final velocity. I think I can do so because this relationship has everything in it, right? Everything in it except acceleration. And since I don't have the acceleration, I could use that one because it has the other 3 things in it and will give me a 4th piece of information. So I just do that. That's what we just did, right? So that becomes 100 equals 1/2 times 0 plus v final times 10. Right? Giving me my final velocity of 20 meters per second. Now, once I have 20 meters per second in the lineup, can I find a relationship that will tell me A? Pretty sure there's one there. And I just used the simplest one to do so. Probably, this one. Let's try this framework again. Okay? I'm going to ignore the graph. I'm going to rewrite my 5 motion equation, my 5 motion variables. Okay, my 5 motion variables. A ball is thrown vertically upward, leaving the ground at 40 meters per second. There is an acceleration of gravity 10 meters per second squared. All right. How high does the ball go? How long until the ball comes to rest? All right, let's see what we can get from this question. Do I know how far the ball went? Do I know the displacement? No. Do I know the initial velocity? Yes, 40. Do I know the final velocity? Yes, what is it? 0. Ball came to rest. Do I know the acceleration? Yes, 10 meters per second squared. That's 3 pieces, isn't it? Now, before I go on, everything with a bar on it has direction. There are 4 things with the bars on them, right? So your first step is to write out the motion variables. Your second step is to see if the problem gives you 3 pieces of information. Your third step is decide what direction is positive. So do you want up to be positive or down to be positive? Pick one. You want up to be positive, so up is positive. So my 40 meters per second, do I make it positive or negative? Positive. The ball was thrown upwards. 0 is neither positive nor negative. 10, should I make it positive or negative? What direction does gravity act, up or down? So I must make it negative. So step 1, write out your motion variable. Step 2, see what motion variables are given in the problem. Step 3, determine the direction of each of those numbers. Make them positive and negative. All right. You kind of understand that what we're trying to do right now is figure out the things that we don't know, the displacement and the time. Will one of these relationships tell us something about the problem? I think I can only use one of these relationships, right? Because only one of them has the combination of the 3 things that are given and one other variable. Wouldn't you agree? So it's this one, I think. That top one. I think I can use that one. Do you see why? It doesn't have displacement in it, and I wasn't given displacement. So I could probably use it to tell me the time. V final is 0 equals negative 10t plus 40. So t equals 4 seconds. All good? So now that I know that t equals 4 seconds, is there a relationship there that will tell me how far the object traveled? Yeah, I've got 2 choices of which one to use. Doesn't make a difference which one you use. Pick one of them. I picked the easier one. And try it. I think the middle one is the easier one. Would you guys agree with that? All right. Now look, the last one isn't particularly hard, but I think you guys know what I'm going to ask you to do tomorrow, right? It's going to be something like this.